So let's talk about the implied domain. So I said already that a function is a rule of assignment, and it's also a domain and range. With many of the functions we'll look at, the domain is something that you can pick, really, right? So if I have like a line, there's nothing that says I can't just make the domain the positive reals, because it would still be a function. So we're going to talk about what I call the implied domain and what your notes calls the implied domain. Most of the time I'm just going to shorten it to domain, and the implication is going to be this implied. And that's going to be the largest set of real numbers such that the function is real and defined. Now they do talk about this in the guided notes. So there's a couple words that I've squiggle underlined here. It's the largest set such that the function is real and defined. So there's really only two things we have to worry about for our functions. Is it real, meaning not complex, and is it defined, meaning there's actually a number that comes out when I do whatever the rule is. So, real, how do I get complex numbers? I get complex numbers by having I, and I get I by having negatives and a square root. So the first thing we are going to want to avoid is negatives and a square root. Defined, all the arithmetic operations are well defined except for division by 0. If I ever divide by 0, that thing is undefined. So there are only two things The first one is negatives and a square root, and the second is zeros in a denominator. That's it. As long as we check for these two conditions, then that's going to be able to give us our implied domain. Okay, so let's look at what this looks like in action. So here's our first example. F of x is 3x plus 4. There's two conditions I'm checking. Are there any possible negatives in a square root? And are there any possible zeros in a denominator? So this thing, no square roots. So my first condition gives me no restrictions. Zeros in a denominator, there's no denominators here that could possibly be 0. So again, no restrictions. So the domain of this, so in the instructions I say you can state it in set or interval notation. So the domain would be all real numbers because there's no restrictions. Or I can say negative infinity to infinity. Okay. If I think about graphing this, this is a line, right? It has slope 3 and y-intercept at 0, 4. So if I were to graph it, it extends infinitely in both directions. So it's going to cover all of the x-axis. So all x values are allowed to be plugged in. Also, think about what you can and can't do. Is there any real number that you can't multiply by 3 and add 4? No. So no problems there, no restrictions. For the next one, let's try, let's do g of x is 2x over 4x minus 5. So g of x equals 2x over 4x minus 5. Same two conditions. Are there any possible negatives in a square root? Are there any possible zeros in a denominator? So for negatives in a square root, there's no square roots that appear in this function at all, so don't have to do number 1. Okay. Zeros in a denominator. There is a denominator here, right? It's 4x minus 5. So whatever I plug into this function, I have to make sure that it doesn't make 4x minus 5 to be 0. Yes, so here, I don't want 4x minus 5 to be 0. If I had that, I'd have something over 0, which is undefined. Okay, so here's my condition, but for domain, since we're talking about x's, I need to rewrite this in terms of x's, right? So I'm going to solve. When does 4x minus 5 equal 0? Well, you add 5, and then you divide by 4. So I get that x is 5 over 4. So if I don't want 4x minus 5 to be 0, then that means I actually don't want x to be 5 over 4. Because if I plug in 5/4, then in my denominator I get something negative. All right, so my domain then is all the reals such that x is not 5 over 4. Now let me double check what they do in Hawks. Okay, so while that comes up, let me say one other thing. Oh, I need to do this in interval notation. So if I want to skip 5/4, so imagine drawing this on the real line, right? I want everything this way, and I want everything this way, open at the 5/4, both of them, because I just don't want the 5/4. So that gives me negative infinity to 5/4 and 5/4 to infinity, and then I'm going to join them with union. Okay, so in Hawks, I think that they ask for interval notation. I'm going to check real quick. Let's see, 4-1. In terms of like ease, definitely using the set notation is easier. They may let you, here we go. They may let you use set notation. Nope, they ask for interval notation. Okay. Dun dun. How do they want this written? Okay, so they do want it in interval notation, so you'll be giving this second one to them. I don't really care, honestly. So if on your work that you submit for the exam, if you write this set notation and you have that correct, and then you got the interval notation wrong or something on Hawks, then that's okay. I can give you points back. Okay, let's look at one with a square root. So for C, let's do h is the square root of, oh, I don't know, 12 minus 3x plus 9. Again, two conditions. One, are there any possible negatives in the square root? Two, are there any possible zeros in a denominator? That's all we're checking for. Now, there's no denominators here that could possibly be zero, so the second condition gives us no restriction. So it basically doesn't matter. The first one, negatives and square roots. Yeah, I do have a square root. So that means I need to make sure that whatever goes in here is non-negative. So my condition would be that 12 minus 3x has to be bigger than or equal to 0. So argument has to be non-negative. Because the second whatever's inside of my square root becomes negative, it's allowed to be 0, it just can't be negative. Once it becomes negative, now I've got complex numbers, and our implied domain says it has to be real. All right, so again, this gives me a condition that I need to solve in terms of x. Okay, so here's my solving I'm going to do. So 12 minus 3x bigger than or equal to 0. That gives me negative 3x is greater than or equal to negative 12. Divide by negative 3. So negative 12 divided by negative 3 is positive 4. And when you divide or multiply by negative, you need to flip that sign. So x less than 4. Okay, so back here, I needed 12 minus 3x to be non-negative. That told me x had to be less than or equal to 4. So my domain is that interval, right? All the x's less than or equal to 4 as interval notation, or a set notation. You know, you have curly brace and you list your variable, and then you just write down the rule you found. Okay, I do want to point out one thing. B was my denominator one, right? Negatives and square root, zeros and denominators. I don't care if there's a 0 in the numerator. That's fine. It's not that 0 divided by something is undefined. If you have 0 pizzas and you want to divide it among your 5 friends, how much pizzas does everyone get? 0 pizza. There's no pizza to be had. Down here, this plus 9 on the outside, that doesn't matter either, because all that matters is that the stuff in the square root is non-negative. This plus 9 is incidental. Okay? So these two conditions, negatives and square roots, zeros and denominators, that's all you're checking. If you don't have a square root and you don't have a denominator that could be 0, then you have no restrictions. Other thing, I said square root specifically. So cube root of negative numbers, that's okay, because negative 1 cubed is negative 1. So cube roots are allowed to do negatives, but square roots are not.